how powerful can scientists make a computer chip? By the turn of the millennium, experts said that tiny chips, packed more and more densely with hundreds of millions of transistors, would generate too much heat. So scientists at Intel developed technologies that enable a microprocessor to do more.
Well, the Core i7 is a pretty radical redesign. In fact, it's one of the biggest changes in the way the PC works in quite a while. So the things we've done are kind of open it up so that it can be fed, open the processor up so that you can feed it with data better.
Intel did this with a number of innovations, such as moving the memory controller onto the chip to achieve higher memory bandwidth, Turbo Boost technology, which increases frequency when the processor detects it has available power headroom, and an integrated power gate, which shuts off power to those cores which aren't in use. Scientists, like Intel fellow Glenn Hinton, say the technologies increase performance and energy efficiency.
The guys in the power management team did a lot of work to reduce the overall and actively manage the power so that if one core is running, we give a lot of power to that so it can run really high performance. That's turbo mode. And if all the cores are working, we adjust the frequency and voltage to make everything work well. And so that whole very active power management went way beyond anything we'd done on any of our previous chips.
At Intel's lab in Silicon Valley, engineers test the Core i7 in a variety of hardware and software configurations, especially in high-end gaming.
I manage a group of guys that our job is to look at the products that Intel's going to be producing and try to explain the benefits in terms that people can understand, that they can relate to things they really do with a PC. So instead of just talking about this thing's 50% faster, we try to find ways to say, okay, what can I do with that 50%? So what Regina is doing here is she's actually going in and playing this game that recently was released, and she'll try out a variety of different settings, whether it's screen resolution or the quality settings in the game. So whenever new games launch, she has to spend just hours in here. It's a terrible job, going through and playing that game over and over and over again until she comes up with the right settings. It's hard.
And the right test.
And the right tests.
Francois Pied-Noel is testing the Core i7 here on an Intel motherboard. So far, he's observed bandwidth that is 2 times higher than on a previous quad-core microprocessor.
So you got the processor, you got the board, and for 6 months you try to figure out where's the problem, here or here. And it's a ping pong between architecture team, and I'm sitting in the middle, taking from the right hand to the left hand and trying to exchange. And we got a lot of smart people working on this, it's a huge team.
This is the lab where we're doing a lot of the functional validation of Nehalem, making sure that it's a good, robust part as we launch it and bring it to consumers. We also check our performance in labs just like this up here in Oregon, as we have our architecture, design, and validation teams all co-located here.
The design of the Core i7, codenamed Nehalem in the lab, involved thousands of engineers in places such as Oregon, California, and Arizona, and in Malaysia and Costa Rica. Ronnie Borkar oversaw the development of the microprocessor across Intel's many organizations, handling tasks like architecture and design, manufacturing, testing, and debugging.
Of course, we have structures, and over time, we've learned to make these structures better and better so that it really progresses very seamlessly. Because, the timelines, one thing which is constant is the timeline when you're going to deliver and what you said you will deliver.
Intel delivers chips on its tick-tock model. The tick represents advances in process technology, such as from 65 nanometer to 45, which was Penryn in 2007. The TOC is a new microarchitecture, in this case, Nehalem.
With a TOC processor, we get the chance to overhaul the complete microarchitecture as well as the platform. The internal of the core has been changed significantly for added performance as well as for better energy efficiency.
So one of the fun things we've been doing even on the previous projects is from an individual contributor's role, when their piece of the design is done and what we locally call it putting it in the freezer, you go and give them a gold balloon.
I've been working on Nehalem since 2003. And so when we eventually get silicon, one of the key moments is the first silicon in the lab and getting it to actually boot a real operating system and run real applications. That's, people compare it to a parent seeing their baby for the first time.
It's both the design engineers, the circuit technology folks, the circuit designers, the validation people, architects, all of the design team. I mean, it's a huge project, a huge team, and it takes, this is rocket science. This is hard stuff.
So this is our baby, our new baby.
This is our new baby. This is the Intel Core i7 microprocessor.
This is the fastest processor on the planet.